And welcome Calculus 2 students. We are going to go over the ratio test today, which is going to let us know whether a sequence diverges, converges, or we might have an inconclusive case. This ratio test involves looking at subsequent terms. You take the next term over the previous term and you see what that ratio is. Now, if that ratio is less than 1, we're going to say that sequence converges. If the ratio is greater than 1, we're going to say that it diverges, and if it equals 1, then we don't really know. So first up, let's look at this particular sequence. I need to figure out what r is, and I know that r is equal to the limit as k goes to infinity of my k plus 1 case, so that's just going to be 10 to the k plus 1 over k plus 1 factorial all over, and then this is just going to be 10 to the k over k factorial. Now I'm going to manipulate this. I'm going to manipulate this complex fraction and see what I get using a little bit of algebra. Alright, what I'm going to do is break this apart so that it's 10 to the k times 10, and I can do that. And I'm going to break this one apart so that it is k factorial times the k plus 1 term, and that is k plus 1 factorial. Then I'm just going to write this one as it sits and then do a little bit of canceling. Ka-chunk, 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 and I'm going to write this down as limit as k goes to infinity of 10 over k plus 1. Note that this then goes to 0, which means that my ratio is 0, and if my ratio is in between 0 inclusively and less than 1, then it converges, so I can say converges. I'm going to play the same game over here and write that down. Alright, if you'll notice what it is, just filled in for my r, and then I broke this first term apart into k plus 1 times k plus 1 to the k. Broke this apart, did that last time. That makes this cancel. That also makes this cancel. Then I can write this as the limit as k goes to infinity of k plus 1 over k, all raised to the k. And then if you will break this apart once again as k goes to infinity of 1 plus 1 over k raised to the k, then this is identically equal to e, which means that my r is greater than 1, so this one diverges. This ratio test is very useful and will come in handy in our next chapter, so get familiar with it and enjoy it. Our next test to look at is the root test, and what we're going to do is we're going to put our series and we're going to take the kth root of that series and find the limit of that as k goes to infinity. If we find that our row is in between 0 and 1, 0 inclusively, we're going to say it converges, very similar to our ratio test. So let's give a go for our first one, and we're going to say that row equals the limit as k goes to infinity of our kth root of a to the k, so that is just going to be this 4k squared minus 3 over 7k squared plus 6 quantity to the k. That makes that nice, that kth root. I like this one so far, and it's going to get me 4k squared minus 3 over 7k squared plus 6. I'm going to take the ratio of this coefficients and say that this goes to 4 over 7. Oops, that's not a 7. And oops, hold. Alright, and that will allow me to say that this sequence converges because my row is in between 0 and 1. Next, I'm going to do a little finagling on this one. I've got to write the row equals. I have that written down, so this is going to be limit as k goes to infinity. That's just going to be a 2. Take these independently. This is going to be k to the 10 over k. And let me rewrite that one just a little bit. I like the 2. That part was nice. So I've got 2 over, and let's write this as k to the 1 over k to the 10th. Kind of get that 10 out of the picture. And I see if k goes to infinity, this thing goes to 0, which means this thing goes to 1, and then it would be 1 to the 10th, so this thing then goes to 2, and by the root test it looks like this thing diverges. Right, on to our next test. In using the comparison test, you have to think of something you want to compare it to, and I would probably, if I wanted to compare something to, I would compare it to the sequence 1 over 2k, because I'm just looking at those ratios there. But in order to compare it to this sequence, what I would have to do is show that this being my b sub k, this would have to be greater than this being my a sub k. So I can just basically write down 2k to the 4th minus 1 is definitely going to be less than 1 over, k cubed over 2k to the 4th, because of the fact that this one is taking 1 out of that denominator, and this thing happens to equal 1 over 2k. So I have shown that b sub k is definitely greater than a sub k. Now let's look at this sequence, and if we can figure out whether it converges or diverges, then we can say what our original a sub k does. So if I look at this one, I could use that ratio test. So let me go and say that r equals, and I'm going to write that down. Okay, I've written this down for my ratio test, and just rolling on with it, I'm going to have that this is 2k over 2k plus 2, and this limit is then going to be equal to 1, and if this limit is 1, that means this thing it's inconclusive. That's what this one is. Hold on. Alright, so this is inconclusive, so let me look at it a little bit closer. So this doesn't work for me, but I'm looking at it a little bit closer. I see that this thing happens to be a harmonic series, and it's 1/2 times 1 over k, where 1/2 is just your constant on this. So this thing diverges because it's a harmonic series. I could have avoided all of this and not done any work if I would have just paid attention. But that happens, doesn't it? Okay, so in B, I'm going to try to compare it to some b sub k. I see this natural log, and what I'm going to do is compare this thing to a 1 over. So in looking at it, let's see, I could take natural log of k over k cubed, and I could say that this thing is going to be always going to be less than k over k cubed, and this thing equals 1 over k squared, and and then this is just going to be one of those p series. Alright, so this being my a sub k, and then this being my b sub k. So now what I need to look at is I need to see what happens here. Whoops, that's supposed to be k equals 2 to infinity 1 over k squared. I'll just say this is a p series where p equals 2, and if p is 2 in this case, then I know that this thing converges. Alright. In our limit comparison test, we're going to have to find an a sub k and a b sub k. My a sub k is going to be my original series here, but we see that it's going to behave like the rational function k to the fourth minus 2k squared plus 3 over 2k to the 6 minus k plus 5, and we're going to say that this thing in the long run is going to look like k to the fourth over 2k to the 6, which equals 1 over 2k squared. And we're going to say that this is our comparison sequence, which is going to be our b sub k. So we need to do this limit comparison test where I take the limit as k goes to infinity of this a sub k over b sub k, and I'll write all that down. Now this factor of 2 doesn't really affect our p series, so we're going to say that this doesn't affect it, and we're just going to look at this k squared over 1, and when I plug this in here, I'm going to get the limit as k goes to infinity of what I have, k to the 6 minus 2k to the 4th plus 3k squared all over 2k to the 6 minus k plus 5, and this goes to 1/2. Therefore my limit is in between 0 and infinity, and then I'll say that this converges. And I also had to talk about the fact that this converges and it is a p sequence, and that's why that 2 didn't matter. In our next one, we're going to be looking at this, trying to figure out what we're going to compare it to. This next one involves a bit of finagling. You can compare it, and all you really got on that was the fact that it does converge, and you didn't really get what it converges to. You just have the fact that it does converge. This is just a set of guidelines, general things on what to choose and why. First trying the divergence test, and after that look to see if you see a p-series or a geometric. If you think you can integrate it, try the integral test, and then it talks about the ratio and root and limit comparison. Those being the ones you don't want to use unless you just have to, as we just saw with the previous example.